We're going to find trigonometric values algebraically using basic trigonometric identities. This first set, and I'm calling this part 1, we really don't have to use the Pythagorean theorem if you know your triples. Remember, with our triples, Pythagorean triples, we know that 5 squared plus 12 squared equals 13 squared. And if you know your triples, this video will be easier. So basically this cosine is x over r. And this tells us what quadrant we're in. So this is quadrant 4. Because this is in between 270 and 360. That's quadrant 4. That means sine is negative. Now if my x is 5, then my y must be 12. In this case, so we have y over r, but since we're in quadrant 4, my sine is negative, because y is negative in quadrant 4. So that's going to be negative 12 over 13. And then tan is just your y over x. So you're just going to take your y over your x. This is your x. Okay? Now what they mean by using basic trigonometric identities, what they want you to do is use sine squared plus cosine squared equals 1. So, or equals r squared. And so basically it's just saying y squared plus x squared equals r squared, which is the Pythagorean theorem, and also the circle formula. So we don't know y squared, x is 5 squared, and r is 13 squared. So solving that, you're going to get the 12 here. Now the next one's similar. They give you sine. Sine is y over r. We're in between 90 and 180 degrees, pi over 2 and pi. That's quadrant 2. I know in quadrant 2 my x is negative. My x is negative. My y is positive. R is always positive. I'm also going to use the fact of knowing my Pythagorean triples on this one, and I know that my triples are 3, 4, 5. Merely, that just means 3 squared plus 4 squared equals 5 squared. You also need to know these for your SAT. You don't want to spend time doing the Pythagorean theorem. Anyway, given that, I know my cosine is x over r. X is negative in quadrant 2, so my x is going to be the 3. So it's going to be negative 3 over 5. And my tan is y over x. So my y is 4. And my x is negative 3. And you just want to write it like this. Doesn't matter where you put the negative at this stage. Okay? Now the next set we will have to use Pythagorean identities because they aren't Pythagorean triples. Thank you. Have a nice day. Bye-bye.